So we're asked for 10 subintervals from 1 to 9. Those are going to be kind of yucky subintervals because look, the distance from 1 to 9 is 8. So we need to take 8 and split it into 10 equal pieces. That means each interval is going to be 0.8 in length. So the first subinterval is 1 to 1.8. Second one's 1.8 to 2.6. And then we got 2.6 to 3.4. Then 3.4 to 4.2. And 4.2, you get the idea. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, what did I do wrong? 9 minus 1 is 8 divided by 10. Split it into 10 equal pieces. I must have messed up an interval here. No, that all looks right. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 9 intervals there. Oh. Did I add wrong? Okay, so 1 plus 0.8, 2.6. I didn't finish my intervals. I didn't finish going to 9, did I? So 5 plus 0.8, so plus another 0.8, plus, right here. This should be 6.6, and this should be 7.4, and 7.4 goes to 8.2, and then 8.2 to 9. Okay. Man, this is going to be a long problem because you got to do the left and the right point intervals and then average them. So if you were to use left endpoint intervals, that means you just use the left side for the heights. So square root of x plus x squared. I'm not exactly sure what this will look like. Let's just say the curve looks something like this. So from 1 to 1.8, we want to estimate the area under the curve, but a left endpoint means we're supposed to use the left side to tell us how high each of these rectangles are going to be. And if it was right endpoint, if this is our interval, we'd use the right side. So right endpoint would under approximate the sketch I made. And then each rectangle is 0.8 in length, right? Because that's the width of our interval, 1 to 1.8. So for the left, we're plugging in all these, all the left sides. So we got 1 square root of 1 plus 1 squared is 2. And here, everything's getting multiplied by 0.8, so we can factor 0.8 out of it. So we got 2 for the first one. We got to plug in 1.8, square root of that. And I'm not a fan of this problem. You can test the student on this knowledge without making them do all these individual tedious calculations. Oh, and these are being added on a list. How many decimal? 3 decimal places. Okay, I've got plenty. So 2.6 needs to go in there. Let's go there. Wait, what did I just do? Oh, I'm trying to do 2.6, and then I got to square it plus that value. So this is roughly what I got. Round up. Could do that for 3.4. Maybe I can pause the video so you don't have to just sit here and watch me type all these in. I'm just plugging in the numbers into the function, but each one requires several different parts. I'll pause the video. So I made a spreadsheet to automate this. Here, I should actually move these up. Well, it doesn't matter. And I found out what I was doing wrong. I did something wrong to make the spreadsheet, but I'll try to share this spreadsheet with everyone so you don't have to do all these tedious calculations. So for our left sum, it would be all these values added together. Okay, so I'm going to type in equals sum D2 to D11. And that's the sum of all those values that I was going to get in those parentheses if I kept going and add that by hand. And I think I actually did, but don't forget though, we factor out that 0.8 at the beginning, right? So we're going to multiply that sum, 285. Here, I'll just copy this, paste, times 0.8. So the left Riemann sum is this, And the right Riemann sum is not going to use the first part, right? So we're not going to use this number for the right Riemann sum. We want to add D3 to D12. And then that value needs to be multiplied again by 0.8. Same reasoning, because we factored out the width at the beginning of our calculation. So the right Riemann sum is this. And then the average between the two is this. So 260.83. There we go. Okay, so we got the thing that the textbook got, or the web assigned. Yeah, so you're going to need to, you're allowed to view the spreadsheet, but I've set it so you can't edit it. So you're going to need to copy the spreadsheet. Should be able to copy it into your own Google Sheets, which is free. Just like most things by Google. Huh? Okay, and then second part, determine the exact area. This just wants you to evaluate the integral. So to determine an exact area, we evaluate an integral from 1 to 9 of our function that we're trying to find the area under. So we need an antiderivative, and luckily the antiderivative operator, you can go piece by piece, similar to the distributive property. So an antiderivative of square root of x means something whose derivative would be square root of x. And so that's 2/3 x to the 3/2. Because a square root is a 1/2 power, when you take a derivative, the 3/2 comes down and multiplies, then it gets reduced by 1. We need to evaluate that from 1 to 9. And then the antiderivative of this piece is 1/3 x to the third. Again, because if you take a derivative of this thing, it does turn back into x squared. And we evaluate that from 1 to 9. So if I plug 9 into this first one, raise it to the 1.5 power, times 2, divide by 3, so I get 18, but I need to subtract that by the lower limit of integration. If I plug in 1, I get 2/3. And then over here, if I plug in 9, 9 to the third, what's 1 times 9? So 729, but then we need to divide that by 3. That's 243. But then you need to subtract that by 1/3. And again, the 1/3 is coming from plugging in my lower limit of integration. Okay. So WebAssign wants an exact answer, so let's give it to him in a fraction form. So over here I've got 54 over 3 subtracted by 2/3. Over here I've got 729 subtracted by 1/3. I'm just going to do that. That's 728 over 3. This is 52 over 3. So we add those together because the denominators are the same. So I get 780 over 3, which I think can be reduced. Yeah, so I got 260 for an exact answer.